Okay, I am just gonna one take this thing. Hi, it is spiritually still no effort November, and I want to tell you about the dumbest thing that I do. So, I've been making flight computers, PCBs, for a long time now, and this one thing that I do has just survived. So, I need to give you a little bit of context, and then I will tell you why the thing I do is so dumb. This is an Ava board. It's one of the flight computers I make, and I write the software for it. I designed the PCB. I used to, in smaller numbers, hand assemble the board, but it doesn't make sense to do that. So eventually, I created a bunch of like pick and place files, and I sent it to a PCB assembly house. They assembled the board, and then it shows up here. But when it shows up here, it's not quite ready to be used. One of the things that I have to do is put this little bootloader chip right below the middle processor. This is functionally like 3 computers in one. The central processor is the same as a Teensy 3.2, and the 2 side processors are functionally Arduino M0s. It's an Atmel SAMD21, and then it used to be Freescale, and then it was NXP, but it's a Mark 20 DX256 VLH7. God. Anyway, so this is 3 computers in one. The design choice has not aged super well. I would do it differently if I were designing it today, but it doesn't matter. Before I can use this, I have to put the bootloader onto the Teensy chip. That's pretty easy. I buy the bootloader chips. I mean, a bootloader is a piece of software, but the bootloader shows up on a chip that comes from the company PJRC. That's the people who make the Teensy themselves. Paul Stoffergen and Robin, I believe. And so the bootloader gets loaded on via that chip. That's pretty easy. You just solder the chip on, and I don't send it to the PCB manufacturing house because you have to buy it from their bespoke little shop, which doesn't work for a PCB assembly service. All right. We've covered some of the basics. The bootloader also has to go on, or a bootloader has to go on to the Atmel chips, the 2 on the side, the ATSAM D21. So the problem with this, in an Arduino M0, there's a thing called it's an EDBG or EBDG or EBDB, I don't know. It's a bootloader chip for the Atmel, but you don't technically need the chip. All you should need to do is load the bootloader onto the Atmel chip once. All right? You should only need to do it once, barring some extenuating circumstances. So it's not as if you need that chip on this board too. And that was the design choice I made when I made Ava. I was like, I don't need a separate bootloader. I can just load the software once and be done. And it'll be kind of annoying to load it, but then I'll be done. So how do you do that? On a board like Signal, a commercial product that I made a couple of years ago, I designed a separate board that had these little pins that come out of it. This is I called it the piggy board because it piggybacks onto Signal. And so the pins give us access to extra pin-out capability that the board usually doesn't have. Like Signal did not come with a USB port. This has a USB port. Signal did not come with SWDIO or clock or reset lines. This has those. Signal did not come with like a 3.3 volt source and a 5 volt source. This has those things. So the reasoning here is like most people using the product don't need access to these pins. I need access to these pins so that I can program and test the board. So that's what this is. This is a piggyback board. When I designed Ava, I knew I wasn't going to be manufacturing it in bulk. And when I say bulk, I mean like greater than 50 units, or at least greater than 50 units within 2 or 3 years. That might change one day, but right now it doesn't. So I did the same thing. I gave this thing little pads on the bottom, and these little pads can be used for programming. But I did not design a piggy board for Ava. This is because I was lazy, and I was like, well, I don't need to do a whole lot. So what I'll do is I'll just take these wires, these little wires that are hooked up to the Atmel ICE that I need to load the bootloader with, and I'll hold them against the PCB as I program the PCB. I'm going to do something incredibly stupid here, and I'm going to mount my wireless mic on the mic that I probably should be using, but it's no effort November, sort of, spiritually. What happens is, and this is going to be hard to articulate, but you'll have to just take my word for it. Up here, I have the Arduino IDE. It's just the programming environment. And there's a button under Tools called Burn Bootloader. This is the thing that we want. We want to burn the bootloader onto these two chips. And so there are 3 pads on the back, one for clock, one for DIO or digital IO, and one for reset. You hit the reset pin, and then the clock and digital IO pins are doing the bootloader burning work. The reset prompts it to go into that mode. So I've broken out some of the pins from this Atmel Ice. I tore apart the ribbon cable to get access to the things that I needed in it. For the most part, there's some that I could just plug into. And I did this, this is circa 2017 at this point. So I tore into this, and it worked okay. Anyway, here's the dumb part. Because I didn't design a piggyback board, I have to hold these 3 pins against the pins on the back of Ava, and they're small enough that you don't really want to solder onto those. They're also not, it only needs to happen once. So I have to hold these 3 pins onto the back of Ava. Nothing's plugged in, but I'm just going to do a demo. I have to hold them onto the back of Ava. You're not really going to be able to see, but you have to imagine it's hard to space these things out. And usually what happens is I need to use 2 hands to do this. But now, I need a 3rd hand. So I've tried doing it with one of these things. Doesn't work. It just doesn't hold the pressure like I need to. And I know there are tools that can do this for me. I just have not bought them. Anyway, I hold it with this 3rd hand, and then I have to use I bring the mouse over the Burn Bootloader button, and then I hold this down, and I click Burn Bootloader, and then it actually does it. I'm not doing it right now. But this is the dumbest thing I do. I thought I would document it. This will be lost to the sands of time if I don't put it on the internet somewhere. And I think, 5-10 years down the road, I'll be like, ha ha ha, that was so dumb. I'm so glad that I did XYZ to fix it. I imagine there are going to be a bunch of suggestions in the comments if anyone watches this about what I could do differently here. I think there's aren't there little machines that have a little bendy arm and you put it down and it puts pressure on a pad? That's the kind of thing I need for this. Because I don't want to make a piggyback board. It's not worth the effort to design a fully new PCB and then assemble a new PCB. And it's not even a thing where you can get a board house to do it, because then you have to generate the pick and place files, and that's a whole set of work on its own. So anyway, I've been using this really stupid solution because every time I do it, it probably only takes an extra 30 to 45 minutes where it would take 5 minutes to program this board, to burn the bootloader. And over the course of several years, those 45 minutes are going to turn into, let's call it 6 hours of troubleshooting, where it would have been 1 hour of total time. And even that is probably not time that I'm going to get recouped. So I don't know if any of this has made sense. Once again, it is no effort November, so I'm putting no effort into this. But I think it's fun to pull back the curtain on some of the things that I'm deeply not proud of. This is a dumb decision that I keep making, where every time I have to program one of these boards, I'm this is so stupid. I'll just do it once, so it doesn't matter. What matters is that it gets done and then we move on. But then there's this whole I'm ignoring any optimization in service of how do we get to the result fastest as possible. And that means not taking the time to slow down and be there's a better way to do this. We should change the way we do this. Anyway, I said I would one take it, and I'm gonna try to keep one taking this video. Is there anything else that I want to add? I don't think there is. This is just the dumb way that I burn the bootloader on the board. And mind you, I'll just put it in here again. This is not how I programmed the flight computer. Every time I load new code, this doesn't need to happen. This is a one-time thing at the beginning of making new Ava boards. It has to happen once, and then it's done. And I do it all in bulk, so it only happens once once, and then it happens again in 1.5 years or 2 years when I need to make another new batch of Avas. So it's 45 minutes to an hour of pure, unmitigated frustration and anger at how stupid it is for me to be huffing and puffing, sweating it out, aligning these wires. But it's only once every 2 years. So like, I don't know, I'll pay for it in frustration. Anyway, I don't know if this video is interesting, but I want to toss more stuff on the Shorts channel, and this is me doing that. You know that Taylor Swift song, This Is Me Trying? I think that's a song. Didn't she make a song called This Is Me Trying? This is me trying. Yeah, it's a Taylor Swift song. Think of this like me singing that Taylor Swift song, except it's different in almost every single way. I hope that helps. Happy No Effort November, spiritually. I know it's December, but spiritually, happy No Effort November. And I think that counts as one taking it. Goodbye. Peace out.